Okay, today we're going to talk about centers of data. Now, centers of data is something that you should have quite a bit of experience with. I know this goes back to at least 6th grade, maybe even a little bit before that. With centers of data, we're talking about mean, median, and mode. So we're looking at ways of describing where data is located, where the middle of the data is, and mean, median, and mode does that for us. So the first one we have is mode. We talked a little bit about mode in the last couple sections, where mode is the most occurring. So you might hear mode, you might hear the word modal. Okay, it's the one that happens the most. Now, if we have data grouped, then we would talk about the modal class, which is which interval, which grouping occurs the most. Sometimes you might have data that has multiple modes. So if we collect a bunch of data, I don't know what it's over, whatever it's over, test scores, and maybe the most occurring test score was an 80. 3 people got an 80, but 3 people also got an 85. So we might have 2 different modes for data, and if that's the case, bimodal means has 2 modes. So if there's 2 different things that occur the most, we're going to call that data bimodal. Our properties of the mode are that it only takes into account common values, and it's not affected by outliers. So the mode's not always the best indicator of our data, so we need to be careful when using mode. It's not always the best. None of these are always the best, though. So, all right, the next one we've got is the mean. So, mean. The mean for data is the average. So the mean is the average. This is like how your grade is calculated in most classes, where it's an average of your points. In order to find the mean, we do the sum of all data values divided by the number of data values. Hopefully that's not brand new to you. So we add up all of our data, we divide by the total number of data values that there are. This gives us the mean. We have some new notation for the mean that gets introduced in this class. So you might see X bar, an X with a bar over it. This means the mean. X bar is how you'll hear me say that. That is a way of saying the mean. Also, this U with that extra long front tail is mu. And that's another symbol that works with the mean. The mean's a really popular way of finding the middle of data, or the center of data. So it is the most common. And it does take all data into account. That means that it takes outliers into account, which can greatly change the mean. It could drag the mean one way or another. So we do need to be careful about using the mean whenever we have outliers. All right, our last middle here is the median. The median is the middle value of an ordered set. Middle value of an ordered set. So we put our numbers in order. This in middle school, or last time you've seen this, you would have seen you kind of cross them off as you work your way in, and then the middle value is our median. If you have an even number of values, then as you cross them off, you're going to be left with 2 in the middle. We have to average the 2 middle numbers. If it's odd, then it's just the middle number. Okay. So if it's even, then there's 2 middle numbers. If it's odd, then there's going to be just 1 middle number. This is also another popular way of finding the middle of data. You'll hear median when we talk about, like if you talk about salaries, so the median starting salary for an architect. You'll hear median when they talk about house values, so the median house value in a certain area is blank, $100,000 or something like that. Median is used quite a bit to describe data. So median only takes into account the middle numbers, and it's not affected by extreme values. So the reason why median is a good indicator of starting salary is there might be somebody who graduates and starts out, an architect, starts out at $100,000. That's not going to happen very often. And so the median allows us to kind of ignore that value and focus just on the middle chunk of people, which are the more likely ones to occur. Okay, so median is not affected by extreme values, high or low, and it only takes into account the mid numbers, the middle numbers. Okay, I'm going to give you a frequency table. And frequency tables we worked with in the last 2 sections. And we're going to find these values from it. So, example. We're going to find each center. Of this really boring data. So, data value. Frequency. Okay, so here's our frequency table. We want to find the mean, median, and mode. So I'm going to start by finding the mode first. We're going to go in the order that we just described them. So mode is the most occurring value, and it's also the easiest to pick out, especially from a frequency table. So our mode is, these are our data values, and this is how many they occur, how many times they occur. So 4 happens once. So our data would be like 4, 5, 6, 6, 6, because it happens 3 times, 7, 7, 8, 9, 10, because each of those happen once. So our mode is the most occurring data value, highest frequency, so our mode is 6. Okay. Our mean is the average. Now we have them all listed, kind of grouped a little bit, and we need to sum all of the data values on top. There's only a total of 10 data values. That pin's shot there. 10 data values, so we can add those up. I'm going to show you a shortcut here in just a minute, but we don't need to necessarily use the shortcut when we only have 10 numbers to add. So I'm going to add my data values. So 4 plus 5 plus 6 3 times, plus 7 twice, plus 8, plus 9, plus, barely out of room, 10. So those are my 10 data values. So 4 was once, 5 happened once, 6 happened 3 times, 7 happened twice, 8 happened once, 9 once, and 10 once. Now we divide that by the total number of data values collected, which is 10. This is an instance where using the fancy fraction in your calculator might speed you up a little bit. So alpha y equals, I'm going to do 4 plus 5 plus 6 plus 6 plus 6 plus 7 plus 7 plus 8 plus 9 plus 10. Oops, and I forgot to divide by 10. So I have a mean of 6.8. It's always good to ask yourself, does that make sense? So in context of this problem, 6.8 is here. It kind of makes sense. It is in the middle of my data values. It is directly between the 2 most popular answers, and so 6.8 does seem like a reasonable value for the mean. Now, in a frequency table, we can kind of speed ourselves up a little bit in calculating the mean. We don't have to type in every single data value. Alternatively, and when we get more data, this is going to be more important, we have that 4 occurs one time. So I can take 4 times 1 in my table. Now, this is kind of silly because 5 occurs one time, but it might speed us up with 6, because 6 occurs 3 times, 6 times 3, which would give us 18, which is what 6 plus 6 plus 6 is. Plus 7 happens twice, so 7 times 2, plus, and 8 plus 9 plus 10, because they only happen once. When we do this, we get the same answer. Okay, so on this example, I wouldn't necessarily use that strategy, but it is going to be a strategy we're going to use moving forward when we have something like 100, or even 50. We don't want to add 50 numbers together, so we need to be a little faster, and that's going to speed us up. The last thing is the median, and the median is the middle number. So if we had our data all listed in order, we could cross them off, and we only have 10 data values, so that's not so bad. However, like I said, we're sometimes going to have more data values, so we need to have some strategies to help us with this. So we can work our way in. So if you imagine 4 and 10 are at the end of our data, so we'd cross it off. Then we'd cross off 9 and 5. We'd cross off 8 with one of the 6's. We'd cross off 7 with one of the 6's. And now we have a 6 and a 7 left, and that's it. So because we have an even number of data items, we do expect to end up with 2 numbers at the very end, and we end up with 6 and 7. Another way to do this is we have 10 total data items. We want to go halfway, so we're looking at the 5th data item, and so this is the 1st, 2nd, 3rd, 4th, 5th, and then we also need to use the 6th, and you just kind of have to remember that. Either way, we get 6 and 7 as our middle values, and we do 6 plus 7, average them, 6 plus 7 over 2, which is 6.5 for our median. All right, let's look at how this would work. The same process would work from data that we have a lot more values. So I'm going to put a new set of data, and we're going to do the same thing. So example. We're also going to do what we call a cumulative frequency column. Kind of put that heading there, so if you're doing something in your homework and it asks for cumulative frequency column, you know where to go back to. So we have a data value, like test score or something like that, frequency of it occurring, and we're going to add a third column called cumulative frequency. So our data values, 3, 4, 5, 6, 7, 8, 9, 1, 1, 3, 7, 15, 8, 5. Okay, so we need to find the mean, median, and mode, and then we're going to complete this graph, this column called cumulative frequency column. First thing that's important to know is how many total data values were collected. So if we consider this test score, so maybe we have a quiz out of 9, quiz score out of 9. This is one person scored a 3, one person scored a 4, 3 people scored a 5, 7 people scored a 6, 15 people scored a 7, 8 people scored an 8, and 5 people scored a 9. All right, how many total people took this quiz? Well, we add our frequency column to give us our total number of outcomes. So 1 plus 1 plus 3, 8, and 5 gives us a total number of 40 people who took this test or quiz, whatever it is. All right, that's going to help us, especially when we find the mean. We said that mode is very quick to find, so mode. Mode is the most occurring, most frequent. You might start using the word frequent to remind yourself highest frequency. So 7 occurs 15 times, so our most occurring value is 7. Okay. Our mean, we need to add up the total, all of our data, and then divide by 40, which is the total number of data items. So for mean, how are we going to do this? Well, 3 occurs 1 time, 4 occurs 1 time. Those aren't too bad, right? We can add those. So if I make a fraction here, I can start adding these. 3 plus 4 plus. Now if I wanted to, I could add 5 3 times, but the faster way to do that is to take 5 times 3. Plus, I could add 6 7 times. 6 plus 6 plus 6 plus 6 plus 7 times, right? That's a lot of work, so I'm going to do 6 times 7. Plus, I need to add 7 15 times. Youch, don't want to do that. 7 times 15 is the same thing. Plus 8 times 8, plus 9 times 5. Oh, I always forget that bottom, huh? Alright, second, enter. Fix it up here. 40. We divide by the total number of data items. So 9 times 5, 8 times 8, 40 is on the bottom. Enter, gives me a mean of 6.95. Does that seem reasonable? Well, 6.95 is almost 7, which is our most popular value. And so that does seem very reasonable that it would fall about here. Okay, we have some data below, we have some data above. We're pretty close to that most occurring item, 6.95. I'm going to show my work for the mean down below. So what we did was 3 times 1 plus 4 times 1. Those are the kind of silly ones. Plus, and this is where it starts to become more useful, 5 times 3. 6 times 7. 7 times 15. 8 times 8. 9 times 5. All over 40. Okay? That's a faster way to add up those values. You're absolutely welcome to add them one at a time, right, like crazy. 3 plus 4 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6. That's 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think that's right? And so on, okay? That's more work. This is the way to speed you up with that. All right, last thing we've got is the median. Median is your middle number. Now we have an even number of data items, so we do expect to get down to 2 middle numbers. So we have 40 total data items. 40 cut in half is 20, so we want to go to the 20th and 21st data items. So we want to go halfway through our data. This is where cumulative frequency might help you. So our cumulative frequency is all of the data that's less than. So for our first column, the cumulative frequency is 1. That would be the data, that would be the number in the cumulative frequency column. This means one number is 3 or less. One data value is 3 or less. At this point, we're looking for how many data values are 4 or less. So 1, 2 data values are 4 or less. Okay, right here, how many data values? We're looking at our data value of 5. So how many are 5 or less? Well, we just added 3 more values that are 5. So that means 5 are 5 or less. And we just keep going. So at this point, how many data values are 6 or less? Well, 7 of them are 6, so we add that 7 with the 5 that we already had, and that's 12. Okay. 12, we add 15 more that are less than 7, so that's 27. Then we add 8 more that are 8 or less, and so that's 35. And then the last 5 gets us to 40. So this is a cumulative frequency column. It's looking at numbers that are less than or equal to that data value. How many are less than or equal to that data value? How does that help us out with finding the median? Well, there's 40 total data values, and I want to find, okay, right here, there's 12 numbers that are 6 or less, and there's 27 numbers that are 7 or less. So my median, my middle number, is going to be 7, because 20 happens between here and here, so that's when we're adding on our 7s. If you don't like that way, then we can look at the 20th and 21st term. So you go 1, 2, 3, 4, 5, 12, and then right here you get to 27. So you know that you hit the 20th and 21st within this group. So our median is 7. You get 7 and 7, and then you average 7 and 7, and that's 7. Okay. This can get to be quite a bit of work. What's cool is we can actually do this in our graphing calculator. So I'm going to show you some steps to do this process in our graphing calculator. So we are going to press graphing calculator device. We're going to press stat. So stat is located. I'm going to read, there we go, stat. And it should open up this. Okay. We go to edit, and it allows us to input a list of values. So there may be a list already inputted. If there is, you go up to list 1 and delete. Oh, I thought there, yep, there we go. Okay, go up to list 1, delete. So you can go up there and press delete on those. Why did mine skip list 2? It goes list 1, list 3. Okay, so I'm going to reset my memory real quick. That was not like that a minute ago. Try it again. Okay, here we go. List 2's back. So I'm going to type my data values into list 1, 3, 4, 5, 6, 7, 8, and 9. I'm pressing enter to move quickly there. And the next column, we're going to type in our frequency. 1, 1, 3, 7, 15, 8, and 5. They should end at the same spot. So what do we do here? We pressed stat. We did edit. List 1 was our data values. List 2 is our frequency. We can press, go back to your main screen. That was second quit. We can press stat, calculate, and we have we're currently working with one variable statistics, one var stat. List 1 is my data. List 2 is my frequency. So we need to get this to say L2. L2 is this little, might not be able to see it, but look at your calculator. Above 2 it says L2. Second that will drop in L2. L1, L2, L3, L4, L5, L6. Okay, so we want L2. So it's right there in blue. So second L2. And calculate. This is going to give us a lot of information, and a lot of information that we just found by hand. So it gives us X bar, we set at the beginning of the lesson, right here. X bar is another way of saying the mean. So the mean is 6.95. Check. Let's see. N is 40. That's our total number of terms. We'll worry about all this stuff later on. Let's see. Our minimum value is 3. Our median, MED, is 7. Check. Our maximum is 9. Okay. And does that cover them all? Mean. Oh, and then it doesn't show mode, but mode's the one that's pretty quick to pick out. Okay, but this is a quick way to get your mean and get your median as well. All right, we're going to stop here. This covers everything from Section 6E besides data that's grouped into classes. I'm going to put that into a second video for you. All right, thanks for watching.